Hello, my name is Nathan Arakawa, and today in this video, I'll be showing you on how to use trigonometric identities. Now, before we talk about how to use trigonometric identities, let's do a quick review on what trigonometric identities are. Now, trigonometric identities are equations involving trigonometric functions like sine, cosine, tangent, etc. that are true for all values of the variables for which both sides of the equation are defined. Now, basically, what that means is that, let's take this equation, for example, right? Now, what that basically means, it means that regardless of what value I substitute for theta, this theta here, regardless of what value I substitute for theta there, the equation will always remain true. So let's say I substitute a 5, a 7, any number you think of for theta, this side of the equation, this side of the equation, and this side of the equation will equal one another. Now that applies for all the trigonometric functions I have listed up here. Now let's go through some of these, right? These trigonometric identities here define some of the functions, like secant of theta is just 1 over cosine of theta. Likewise, cosine of theta equals just 1 over secant of theta. Or here, sine of theta squared plus cosine of theta squared equals 1. These are called the Pythagorean identities. Here we have the angle addition and angle subtraction identities, like sine of x plus y equals sine of x times cosine of y plus cosine of x plus sine y. Here, this one here is the angle addition. You can tell by the plus here. Now, these are the angle subtraction ones. You can tell by the minus sign here. There's one for tangent, and there are two for tangent. Of course, angle addition and angle subtraction. Both of these actually you can derive from, knowing that tangent is just sine over cosine. You can do sine of x plus y over cosine of x plus y to get this equation here, tangent angle addition. And likewise, but you would use the angle subtraction for sine and cosine to derive tangent x minus y. Here are the double angle addition formulas and subtraction double angle addition formulas. These are derived from these formulas right here, of course. And here are the half angle formulas down here. The one for tangent can also be derived using the fact that tangent is just sine over cosine. Now, those are some trigonometric identities. And most times when solving equations or proofs that involve trigonometric functions, we use those. But we also sometimes use these. Now, same thing for the last trigonometric identities I just showed you. Now, regardless of what value I substitute for x, sorry about that. Now, regardless of what value I substitute for x, this equation will always be true. Both sides of the equation will always equal each other, regardless of what value I substitute for x. It applies for all of these too. Now, let's go and solve our first proof that involves trigonometric equations. Now, in this equation right here, right, how would I prove that this side and this side are equivalent? Now, before we start using any trigonometric identities, I like to simplify the function so we can use some basic algebra. Now, to make solving this or proving this equation easier, let's start by distributing the sine of x to these two terms here, cotangent of x and tangent of x. Now, what that'll look like, it'll be sine of x cotangent of x plus sine of x tangent of x. Now, we used a little bit of algebra and the distributive property to come to this. Now, I'm going to apply some trigonometric identities. Like the trigonometric identities that I had listed earlier in this video, we know that cotangent of x is just 1 over tangent of x, which is just, well, tangent is just sine over x over cosine of x, which means that cotangent is cosine of x over sine over x. Now I'm going to substitute that for cotangent of x here. And we'll do likewise for tangent here. We know that tangent, using our trigonometric identities, is just really sine of x over cosine of x. So I will be substituting that for tangent right here. Great. Now, using a little bit of algebra, we know that sine of x over sine over x is just 1, so we have cosine of x here, right? And we know that sine of x times sine of x, well, that's just sine of x squared over cosine of x. Now, we're going to continue solving this proof by using a bit more algebra. We're going to try to give cosine the same denominator as this term over here, so we can add them. So that'll be cosine of x squared over cosine of x. We multiply cosine from here to that to give them the same base, plus sine of x squared over cosine of x equals secant of x. There we go. Now, using another trigonometric identity, adding cosine of x squared plus sine of x squared is just 1. I'll write that identity here. Cosine of x plus sine of x equals 1. There we go. And now, using another trigonometric identity, our final trigonometric identity for this example, we know that 1 over cosine is just equivalent to secant. Now that we have solved this proof and proved that this equation is true, you can see how trigonometric identities come in handy. Now, you can also use trigonometric identities to simplify terms or equations like this one right here that I'm circling right now. And this is essentially what we did to prove that this side of the equation equals secant. Okay, now let's do another one. This is our second example, and it will be our final example. Now, how would we go on about to solve this equation? Well, from what I see right off the bat we can use 2 trigonometric identities. The first one we can use is regarding to sine of 2x. That looks a lot like the double angle formula, which is, sine of 2x just equals 2 sine of x times cosine of x. Now we're going to substitute that for sine of 2x here. And then, well, I see another trigonometric identity we can use. And that trigonometric identity has to do with cosine of 2x, which equals cosine of x squared minus sine of x squared. Now I'm going to substitute this for cosine 2x. Oops, there we go. I added that. Now we have come to this result. But we're not done yet, because we still haven't proved that this side of the equation equals tangent. But how can we reach that? Well, thankfully, there is another trigonometric identity we can use. And it's regarding the one here. That one right there. We know that sine x squared plus cosine of x squared equals 1. And from there, we can substitute this for 1, right? So I'm going to do that really quickly. There we go. And now that we have converted this term to this, we can now simplify this using a little bit of algebra, and hopefully we can get it to equal to tangent to prove that this equation is true. Now from what I see, sine of x squared minus sine of x squared is just 0, so those two will cancel out. And we will be left with cosine of x squared plus cosine of x squared, which we can also simplify down to 2 cosine of x squared. Oops, there we go. Now, using more algebra, we know that dividing 2 by 2 is 1. Let's make a clear section here. We know that dividing 2 by 2 is 1, so now we are left with sine of x times cosine of x equals cosine of x squared. And we know that cosine of x squared is just really cosine of x times cosine of x. We will substitute cosine of x times cosine of x for cosine x squared. And knowing that, and using more algebra, we can eliminate these 2 cosine of x terms. And we are left with sine of x over cosine of x. And using final trigonometric identity, we know that just equals tangent. And now we have proved this equation to be true. Now, from these 2 examples, I hope that you have learned how to use and apply trigonometric identities in order to simplify and solve trigonometric functions and equations. Thank you for watching my video, and I hope this video has helped you and taught you on how to do and use trigonometric functions. And I hope the math for this gets a lot easier for you now that you watched my video. Thank you, and have a good one.